Everyone, welcome back to my channel Learn Statistics with Mustafa. In today's tutorial, we're going to solve this practical example step by step, applying statistical analysis to a real environmental data. So, during a field study, water samples were collected from two here, not three, two different river seats, group A and B. For example, this refers to forest, and this, for example, to crops area, for example. For each seat, 5 measurements here were recorded for temperature, 5 here, and pH for each group to assess the water quality. Questions. One, create a data frame or plot these results in Excel and import it as a CSV file into RStudio, or create a data frame including the two groups and their respective values for temperature and pH. Draw the results using appropriate plots, either box plot, bar plot, to visualize the differences between groups, and calculate skewness of each continuous variable temperature and pH. Compute the univariate descriptive statistics, mean, median, standard deviation, minimum, maximum, etc. for each variable. Use bootstrap resampling 95% confidence interval to estimate the uncertainty around the mean for each variable. Assess the assumptions of outliers, normality, and homogeneity of variance. After that, compare group A and B here, A and B, statistically using t-test, student test, or a non-parametric test if we have assumptions when we have for example, identifying extreme outliers or a non-normality distribution or a heterogeneity variance. So which is refers to if the assumptions are violated, and evaluate the effect size using Cohen's d function test. Organize and visualize the results of statistical tests in a box plot, summary figure. Write a short conclusion paragraph summarizing the main findings. So, step one, first we have created or we create data frame called, for example, here data1, contain these three variables. One group in variable refers to group A and B, and the second temperature refers to values of each group. I think we have here we need to add the value of pH here, like this way. Yes, pH, and check the data1, and then the, for example, data1 to compute, for example, number of rows and columns. Here we have 12 columns, and which refers to 6 values of each group. So and 3 variables, group, temperatures, and pH. So we're not including dissolved oxygen for this example. The second question, or the step 2, refers or corresponds to visualizing the data. Next question refers to, or we might need to visualize our results using appropriate plot, either box plot or bar plot. For example, this command using ggplot function from which package? From, I think, ggpabber, yes. Data1, because we have called it as data1, ICT graphical, and the right for each x-axis here group, we have group variable, and fill to, for example, distinguish it between it with color, temperature as y-axis, and here gm boxplot from ggplot2 package. We can put a command here and click to run. So this results of this figure refers or shows the distribution of temperature values on each group, or the distribution of each group on temperature values. Then we might need to draw the distribution of each variable or each group using, in this case, the pH variable. we need only to replace or substitute this variable with pH and click to run. This box plot refers to the distribution, in this case, of pH value according to a group A and B. We don't need to use the dissolved oxygen here. So moving now to draw a bar plot, bar plot, to represent the mean, for example, value here, fun equal to mean of each variable by group, for example, and click to run. Here also ggplot, data1, comma graphical x and y and fill group, and geom bar in this case instead of geom box plot, stat equal to between double quotation marks summary and comma fun equal to mean when we want to draw or represent the mean value of each group. Here, for example, I think nearly to 15. In this case, we might need to, for example, draw a standard deviation. We need only to write here, click to run. Here, for example, standard deviation of each group and the mean value, the same way of max and median. So this all results or figure refers to the metrics like minimum, maximum for each variable, and also box plot for the distribution of each group. Moving to third one refers to the skewness used in the moment package moments library. We calculate skewness for both variables, skewness for temperature, and skewness for pH. This value refers to the negative value of skewness, minus 0.11, approximately 0, meaning the distribution is nearly symmetric or normal. And the pH skewness is slightly, is equal to 0, which refers to, a Gaussian distribution or normal distribution. So skewness close to 0 refers to symmetric distribution, and if the skewness is positive, in this case we have right, skewed, and if the p-value here, if the skewness value is negative, in this case we have a left skewed. Moving now to the fourth question, we use an attach function to separate the data between to separate the variables of our data. And instead to use mean data, for example, here, like this way, mean, for example, data1, and select temperature. So we can use attach before function on our data, appropriate data. And instead to use mean like this way, mean data, and select variable, we might need only to write mean function and select between parentheses the variable that which we want to compute their mean value. So the mean value is 16.68 and the mean pH is 7. And here, if we want to compute the mean or the standard deviation of the median or the minimum or maximum for each group, so we need to add group by and select the group in variable and summarize it and select mean between parentheses temperature. For example, this mean value of group A is 15.4 and group B is 18. The standard deviation, the same case, this is the results of standard deviation of each group, the median and minimum. Instead to click to run, I can click only with the same time on control and past, I think. And also for the max, this is the first to the descriptive, or we have assess or compute univariate descriptive statistics, mean, median, standard deviation, mean, max for each variable. Also for not only each variable, but for each group, depend according to variable. According to each variable. So moving now to the fifth question, which refers to bootstrap resampling. As we have discussed before about attach function, The bootstraps, to estimate the uncertainty around the mean, we used bootstrap here. For example, we called boot underscore means. We used a bootstrap resampling with 5,000 replicates. And for temperatures here, for example, and click to run, and then the quantile to assess the, for example, the 2.5% and the 97.5% value of the mean. In this case, the mean value of the mean temperature must be ranges between 15.93 and 17.43. In our case, the mean temperature is 16.68. So in this case, the 95% confidence interval ranges between these two values. So the comment here, we might need to conclude that, for example, I am or we are confident, we are 95% confident that the mean temperature is 16.68. So also the sample mean of these temperatures lies within this range. So we are, or I am 95% confident in this estimate. On other hand, the 95% confidence interval ranges from 15.93 and 17.43. The same case for pH. Here, for example, this we are 95% confident that the pH value or the pH mean lies with this range between 6.9 and 7.1. So we are confident, or we are 95% confident in this estimate. Moving to the sixth question, which refers to assessing the assumptions of outliers using identify outliers from, I think, Statistics package, which is refers to the first assumption. So we can click to run. This output indicates that there is no extreme value detected using identify outliers. So the second assumption refers to assessing whether there is a normal distribution using Shapiro-Wilk test. Both groups here follow a normal distribution because the p-value of each group is more than 0.05. And the third assumption refers to homogeneity of variances using var.test, which is a variance or Fisher test. So in this case, the p-value is more than 0.05, which indicates that the variance test confirms equal variances. We have a homogeneity of variance. The seven questions refers to, no, we need before to test whether there is a significant difference between groups using t-test, which is students test to compare groups. So, and we need to click to run. So in this case, p-value is very significantly less than 0.05. So in this situation, we have a significant difference between group A and group B from using the test. Then we might need to assess the effect size using what? Using Cohen's d-test from Statistics package, and click to run. From Cohen's d-test, the effect size are equal to minus 5.19, which refers to a large effect, this magnitude of the difference. Then we might need to call this comment or code as a test for example, to draw the results in the box plot. And this seven question, I think we might need to represent or organize and visualize the results of statistical tests in the box plot. So this is the reason why we have called this comment as, for example, test. So ggplot data 1 and the aesthetic group x, y, x axis equal to group. This is very simple. Y equal to temperature, file equal to group, plus box plot from ggplot package, and then labs, write labs subtitle, get test label, and here put the test, and the name test here we have called as test, which refers to the output of the test. And here we put the name of this test as test also, detailed equal to true, and click to run. And this figure summarizes the whole results of our statistical test, of student test, the results of the test. The p-value is very significantly, and size, which is 6 for each group, which refers to 12. And the x-axis or group or independent, or also called as explanatory variable, and the temperature is a continuous variable. So we can conclude that there is, as conclusion, here we write a short conclusion paragraph summarizing the main findings. Our analysis shows that temperature differs significantly between group A and B, while for this only temperature we have not, for example, assessed whether there is difference significant for pH. We have only assessed for temperature. So both variables, I think, follow approximately normal distribution, and no outliers detected. The bootstrap analysis provides strong confidence in our mean estimates. This example demonstrates how to perform a complete statistical workflow from data visualization to hypothesis testing, whether there is extreme outliers, normative distribution, and the third one, which refers to homogeneity variance. Then we assessed using t-test whether there is significant difference between groups, and the coins test to assess the magnitude, effect size, and then we have also created this figure which are including the output of the test. So I think this is all of these questions or situation 2. So thank you for your watching. If you found this tutorial helpful, don't forget to like, share, and subscribe to learn statistics with Mustafa for more practical lessons. See you inshallah in the next video, and I will put whole comment or this code in the comment below, and see you again. See you later inshallah.